The mathematical form, however, is not required in the syllabus of JEE or any other examination. We will just look at what the form is. The heat transfer is equal to this quantity, where H is the heat transfer coefficient. This comes from Newton's law of cooling. We will be looking at Newton's law of cooling in a short while, but for now just know that this is how the expression of heat transfer in convection looks like. Next, we look at radiation. Unlike conduction and convection, radiation does not require any medium to transfer heat. So no medium is required to transfer heat. In fact, radiation occurs best in case of vacuum. Heat is transferred by electromagnetic waves. The radiation heat transfer is governed mathematically by something known as the Stephen's law. From Stephen's law, we say that the emissive power of a body is equal to this expression. This E is the emissive power. Sigma here is known as the Stephen-Boltzmann constant. Epsilon is the emissivity of the body, and T is the temperature of the body. So if we have a body at temperature T and with emissivity epsilon, A being the A being the surface area exposed, then the emissive power or the rate of energy lost by that body through radiation will be equal to sigma A epsilon T to the power 4. The value of the Stephen-Boltzmann constant is found out to be this. Something which is new to us is the emissivity. Let us study that. Emissivity is nothing but the extent of radiation heat transfer. This varies from 0 to 1. Epsilon is equal to 1 in case of a black body. Note that when we say black body, we mean that this body is a perfect emitter and a perfect absorber too. When we say absorber, we need to look at another expression. We have something called absorptivity. This is the extent of absorption of radiation energy by a body. So if we have a body, the extent up to which it is going to absorb heat from other sources by radiation is basically denoted by alpha. This is going to be energy absorbed by the energy incident. So if we, let's say, have a body on which incident energy is, say, 1000 joules and the body absorbs 500 joules, then our absorptivity will become equal to 1 by 2. Kirchhoff's law says that absorptivity alpha is equal to epsilon for all such bodies. These bodies are generally known as gray bodies. This is also true in case of a black body, in which case both are equal to 1, which is basically the statement of a black body. Let us look at cooling by radiation. This is the most general phenomena you will be observing, because if you keep a hot red hot iron bar in air, the iron bar cools to a normal temperature or the room temperature through two modes of heat transfer, one being convection, other being radiation. So how that cools, let us look at it. Say this is our surrounding. Our surrounding, say, is at T infinity temperature. Note that T infinity is just an expression. This does not mean that temperature is infinite. Say we have a body here, body A. It is at a temperature T0. Its emissivity is epsilon and its surface area is A. So the power emitted or the emissive power of this body is given by Stephen's law, say as sigma A epsilon T0 to the power 4. The surroundings are going to impose a radiation heat exchange with this body in form of this formula. Say that is denoted by PS, and it is going to be sigma A T infinity to the power 4. Note that there is no epsilon involved in this expression, because we are talking about surroundings right now. So if the body has epsilon as the emissivity, its absorptivity alpha is also going to be epsilon. So the power which is absorbed by this body, say that is, let's say, PA, this is going to be sigma A alpha T infinity to the power 4 or sigma A epsilon T infinity to the power 4. If we consider any temperature T of this body at any instant of time, the net power emitted or the net power given off by the body is going to be equal to the power which it emits minus the power which it absorbs. So net P radiated is going to be equal to sigma A epsilon T to the power 4 minus T infinity to the power 4, provided T is greater than T infinity. This is how a body loses heat to the surroundings by means of radiation.